We want to find the right-hand Riemann sum using 8 subintervals. So remember, we're going from 0 to 4. Now, instead of having a base of 1 like the last ones, each rectangle is going to have a base of 1/2. Right, so each one of these rectangles that we're going to create has a base of 1/2. I won't write it out for every one of them, but each one's 1/2. And we were asked to do a right-hand Riemann sum. So the right side of each interval is where we get our height. So from 0 to 1/2, when x is 1/2, we plug that in. That's 1.75. That's the height of our rectangle. From 1/2 to 1, we put 1 into the function, we get 3 out. That's the height of our rectangle. And so on. All right, and then again, at that last interval, we don't end up with a rectangle because at x equals 4, y is 0. Now we're going to kind of go through the process of finding the area of all these and adding them up, but not doing it all by hand exactly. We're going to set some things up, and then we're going to look at how to do it with a calculator. So for this first one, if we're looking at the area of the first rectangle, what's the base of the rectangle? 1/2. And then how do we find the height? Plug it in, right? We have to plug in the x value. So here we have x equals 1/2. We have to plug that into our equation. All right, we're putting it in here. So we're going to have 4 times 1/2 minus 1/2 squared. Oops. That's going to give us the area of the first rectangle. We're not going to work that out just yet. Just leave that. If we look at the area of the second rectangle, you're going to have to add that up. The base is still going to be 1/2. But how are we finding the height of this one? What x value are we putting in? 1, right? That finds the height of this second rectangle. So 4 times 1 minus 1 squared. Plus, we did the area of the third rectangle. We have a base of 1/2. And this time, we have to put in 1.5 or 3/2 for x. So 4 times 3/2 minus 3/2 squared. Alright, so we can see how that's going to get kind of boring after a while, right? Because we still have 5 more to go. So I'm not going to write these all out. I'm going to kind of skip to the last one. Our last one, how many rectangles are we going to do? Technically, how many subintervals do we have? 8. Although we know like the 8th one kind of comes out to be 0. I'm still going to plug this in. Take that into account. We have a base of 1/2. To find the height, it would be 4 times 4 minus 4 squared, right? Because that's the right side of this interval. What? We are going to tie in some stuff we did yesterday, right? With the sums. Alright, so rather than doing all of these calculations on our own, this is where our summation notation or sigma notation comes in from yesterday. We can find the sum of all of these rectangles, Riemann sums, right? We're starting off at n equals 1. And then how many subintervals do we have? 8. So we're going from n equals 1 to 8. Right, so that's going to be the number of subintervals. Well, let's look at what we're adding. They look very similar. right? Each one of these has a 1/2 out in front. And then each one of them has 4 times a number and then something squared. Right, so there's similarities in each one of these. We have 1/2 times, we're going to have 4 times some number minus that same number squared. Right, each one of those terms looks like this. The only thing that's changing is what's in those parentheses. So let's figure out how can we represent what's in those parentheses. Let's look at the numbers that we're dealing with here. Oops. Right? We've got 1/2 and then 1 and 3/2 and so on. So let's look at that sequence. 1/2, 1, 3/2, the next one would be 2. What is that going up by? What's our common difference? 1/2, right? So yesterday we talked about arithmetic sequences. We have a common difference of 1/2, so it's going to be 1/2 times n plus c. Remember our formula, a sub n equals common difference times n plus c. So our common difference is 1/2 because it goes up by 1/2. C is always going to be the first term minus that common difference. So what's 1/2 minus 1/2? 0. So really what ends up going inside these parentheses here is this number divided by 2. Right, let's look at it. The blue highlighted part here. If we do the first rectangle, we put 1 in, we get 1/2. 1/2, and it looks just like this. Right, for our second rectangle, we put 2 in. 2/2 gives us 1. Right, so this looks just like that one, and we kind of make sure that we set this up right. Third rectangle, we get 3/2 in there. Right, so this is our sum that we can use to figure out the area of those 8 rectangles added up. Now, we could use those rules we talked about yesterday and kind of break this all down and use the formulas, but we can also do it with our calculator, and we'll have to wait to show you how to do it with the calculator tomorrow. Nice try. Homework is the worksheet. You guys can skip number 2 and number 5 for tonight. Don't cross it out completely. We'll probably look at them later, but you don't have to do 2 and 5.